So we found the state psi naught, the ground state for the simple harmonic oscillator, and it has the form right up to normalization factor, which we can figure out, but we don't need it for our purposes. A e to the minus the mass, the frequency, position squared over 2 h bar. And we can now figure out what the energy associated with the ground state is by the fact that h psi equals E naught psi naught. So when we apply the operator, the Hamiltonian operator, we get an eigenvalue equation, and we'll get the actual value of the energy there. And so, of course, H is in terms of let's write it like this: H bar over I d by dx, right? It's p squared over 2m plus m omega naught x squared, right? So let's plug this in, and what we want to do is 1 over 2m h bar over I d by dx. We want to do that twice. Then we add omega naught x squared. We act on psi naught, and this will give us something proportional to psi naught. And the question is, what is that quantity? Right, that'll pop out from this, and we'll be able to get our ground state energy. So let's plug in this psi naught. A just goes along for the ride. So we'll get an A here, and an A here. We can just cancel the A. So we have 1 over 2m minus h bar squared d by dx. So we have to do this twice. So let's do it once, and then we'll do it again. So when we do it the first time, we're going to pull down this term, and we have 2x. So we get a minus m omega naught x over h bar, because we have a factor of 2 here that cancels the 2 on the bottom. We get e to the minus m omega naught x squared over 2 h bar plus m omega naught x squared e to the minus m omega naught x squared over 2 h bar. And this is equal to E naught times e to the minus m omega naught x squared over 2 h bar. So let's do this additional operation here. So we have 1 over 2m minus h bar squared. We're going to take the derivative of these two, in x of these two terms. So we have a chain rule. So for the first term here, we just get 1 replaces that. So we have minus m omega naught over h bar times the exponential. For the second term, we're going to bring down a minus from here, and there's going to be an x term, so we'll have an x squared here, so we'll have an m, and then we have an m omega naught over h bar, so we're going to end up squaring that. So we have an m squared omega naught squared, we have an x squared over an h bar squared, and then we have the exponential function. So we're done with that, and we just carry along these. Let's just work it out. Square each term. We're done there, and this is equal to this unknown E naught times the exponential term. sorry, I'm not squaring the omega or the omega naught, squaring the x. And so, let's see, when we simplify these terms, what do we get here? We have an h bar minus and minus, that's a plus, h bar omega naught over 2. We have a minus m omega naught squared x squared over 2. We have a similar term here, but positive x squared over 2. We cancel the exponential functions. And this has to equal to E naught, right? We'll cancel this, 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 and this. And therefore, all we have is this. So E naught, our ground state energy, is h bar times the angular frequency divided by 2. And now we know the entire spectrum because the higher energy terms all increase by h bar omega naught. So the energy spectrum is En. We have n plus 1/2 h bar omega naught. And we've solved for the entire spectrum for the simple harmonic oscillator.